a look at this helium-filled balloon. How many atoms of helium are in this balloon at STP? Is this a problem we can even solve? Of course it is. We just need to know a few things first, such as what the heck is STP? What is the volume of the balloon? And what volume would 1 mole of any gas occupy at STP? First off, what is STP? Well, my definition might be slightly different from the chemistry definition. STP are the initials of the great 90s rock band Stone Temple Pilots. S means standard. ST means standard temperature, which is 0 degrees Celsius. SP stands for standard pressure, which is 760 torr, or 1 atmosphere, or 760 millimeters of mercury. So STP stands for standard temperature and pressure. This brings me back to that hunka burning love, Amadeo Avogadro. His name is forever associated with the fact that there are 6.02 times 10 to the 23rd things in a mole. Back in 1811, Avogadro published a paper in which he theorized that samples of different gases, which were at the same temperature and pressure, contain the same amount of gas molecules. At this time, he was not able to calculate the number of molecules. However, when that amount was determined almost 100 years later in 1909, the quantity was named after him. Hence, we know the value of 1 mole of any substance as Avogadro's number, 6.02 times 10 to the 23rd atoms or molecules. That is all fine and dandy, but what does it have to do with mole facts? Well, it just so happens that at STP, standard temperature and pressure, 0 degrees Celsius and 1 atmosphere of pressure, any gas will occupy a volume of 22.4 liters. This is our final mole fact and allows us to convert between moles and liters, but only when dealing with gases at STP. So let's go back to our balloon. If this balloon has a volume of 3,240 milliliters, how many atoms of helium are in the balloon? Okay, we have to convert 3,240 milliliters of a gas to atoms of helium. Do we have a conversion to do this? Nope. We cannot do this conversion directly, so this conversion will have a few steps. We are dealing with a gas at STP, so we know that we will be using our new mole fact. Keep that in mind while solving mole-type problems. For a gas at STP, you will most certainly be using the fact that 1 mole of any gas equals 22.4 liters. Do not use this conversion factor if the problem involves solids or liquids. 22.4 liters per mole can only be used with gases. Let's figure this out. Start with 3,240 milliliters of helium in the train track. Set up a long train track because this is a 3-step conversion. In order to use our new mole fact for gases at STP, we need a volume in liters, not milliliters. Remember, there are 1,000 milliliters in 1 liter. Milliliters must cancel. So I'm going to put 1,000 milliliters of helium on the bottom of the train track and 1 liter in the top section of the train track. Doing this causes milliliters of helium to cancel. Stopping here would give us liters of helium, so we must keep going. At this point, we can use our new mole fact. The helium gas in the balloon is at STP. So we know a mole of any gas at STP would occupy 22.4 liters. This mole fact will allow us to convert from liters to moles. Liters have to cancel. So 22.4 liters of helium will go in the bottom section of the train track, which means 1 mole of helium goes in the top portion. This causes liters of helium to cancel, leaving us with moles of helium. We are not looking for moles of helium. We are looking for atoms of helium. We have one more step. Converting between moles and atoms is as easy as using Avogadro's number. there are 6.02 times 10 to the 23rd atoms of helium in 1 mole of helium. Moles have to cancel. So 1 mole of helium will go in the bottom section, meaning 6.02 times 10 to the 23rd atoms of helium goes in the top section of the train track. This causes moles of helium to cancel, leaving us with atoms of helium. Extraordinary. To perform this calculation, multiply the numbers on the top of the train track together and divide by the numbers on the bottom of the train track. In this case, we will need to multiply 3,240 times 6.02 times 10 to the 23rd, then divide by 1,000, and divide by 22.4. This will give us 8.7075 times 10 to the 22nd atoms of helium. The number given to us in the problem has 3 significant figures, so the answer can only have 3 sig figs. The correct answer to this problem is 8.71 times 10 to the 22nd atoms of helium. Hey, now you try one. The setup for this problem is exactly the same as the example I just worked through. Pause the video and use the mole facts to determine the number of molecules in a balloon filled to the same volume, 3,240 milliliters, with carbon dioxide instead of helium. Showing your work with units and labels is more important than writing the answer to the question. How'd you do? Are you confused? Did you get the exact same answer? Well, you should have. The conversion works for any gas. If you have 3,240 milliliters of a gas at STP, you have 8.71 times 10 to the 22nd atoms of that gas. It doesn't matter if it is helium, carbon dioxide, or any other gas. 1 mole of any gas at STP will occupy 22.4 liters. Now you know how to solve mole problems involving solids, liquids, and gases. All you have to do is practice to become an expert at these types of calculations. So until next time.